integrate x squared over x cubed minus 4 dx. Solution. For us to get the integral of this expression, we shall let u equals to x cubed minus 4. Therefore, the integral becomes the integral of x squared over, we now replace this one by u, then dx. Okay, we need to write dx in terms of du. So we shall differentiate this equation with respect to x. So we get du dx, when you differentiate this equation with respect to x, then we have 3x squared. When you differentiate -4 because it's a constant, we get 0. Therefore, we have, when you get the derivative of this equation, then we have du dx equals to 3x squared. Now, from here we can rewrite this equation as du, we multiply both sides by dx, therefore du equals to 3x squared, then dx. But we want to make now dx the subject so that we express dx in terms of du. So we divide both sides by 3x squared, so this and that cancels. So we have du over 3x squared equals to dx. So now we have expressed dx in terms of du. So we came here and replace dx with this one. Therefore, the integral becomes x squared over u, then we replace dx by du over 3x squared. Now from here we can divide x squared and x squared so that the integral becomes 1 over u, then du over 3. So from here you can see that we have a constant, which is 1 over 3. We take it outside the integral sign so that this becomes 1 over 3, the integral of 1 over u, then du. Now from this we can now integrate 1 over u. So when you integrate 1 over u, you shall have 1 over 3. When you integrate 1 over 3, you get the natural logarithm, which is ln of u, then plus a constant of integration. But remember, in our equation, we didn't have u, just introduced u for the convenience of working. So we go back and substitute where there is u, we substitute with x cubed minus 4. Therefore, this equals to 1 over 3 ln of now x cubed minus 4, then plus a constant of integration, Example 2, they want us to get the integral of 6x squared all over x cubed minus 4, then dx. Solution. So from here, because 6 is a constant, we take it outside the integral sign so that we have the 6 integral of x squared all over x cubed minus 4 then dx. As usual, we let u equals to x cubed minus 4. So where there is u, where there is x cubed minus 4, we replace with u. So that our integral becomes 6 integral of x squared all over now u. This is our u now. Then, of course, dx. Now, we again need to write dx in terms of du. For us to achieve that, we differentiate this equation with respect to x. Therefore, we have du dx. When you differentiate the equation with respect to x, then we have 3x squared. Negative 4 is a constant. When you differentiate a constant, you get 0. So du dx equals to 3x squared. Sorry. So we multiply both sides by dx, so that we have du equals to 3x squared dx. Since we want to express dx in terms of du, we make dx the subject of this equation by dividing both sides by 3x squared. 3x squared, 3x squared. These and that cancels. Therefore, dx equals to du over 3x squared, like that. So then our integral now becomes, we now need to substitute dx by du all over 3x squared. So it becomes 6 the integral of x squared all over u, then we substitute it with du all over 3x squared. So from here you can see that x squared will cancel with x squared, so that we remain with 6 the integral of 1 all over u du over 3. From here again we take a constant out, which is 1 all over 3. Therefore our equation now becomes 6 all over 3 the integral of 1 all over u then du. You can divide here so that we have 3 there 2, so we have 2 the integral of 1 all over u then du. When you integrate 1 all over u, you get the natural logarithm, which is ln of u. So this equals to 2 ln of u, of course, plus a constant of integration. Therefore, this equals to 2 ln of, we now substitute the value of u by x cubed minus 4. X cubed minus 4 plus a constant of integration. So we have example 3. They want us to get the integral of 2x squared all over x cubed minus 4, and then dx. Solution. We shall let u equals to x cubed minus 4. So our integral now becomes the integral of 2x squared all over, now this is now u, so it will be u then dx. This is the same as we take 2 outside because it's a constant. It will be 2 the integral of x squared all over u then dx. Again, we need to express dx in terms of du. For us to achieve that, we differentiate the equation with respect to x. Therefore, du dx When you differentiate x cubed, you get 3x squared. When you differentiate negative 4, you get 0 because it's a constant. So this is the same as du equals to 3x squared then dx. So from here we make x the subject. We make dx the subject by dividing through by 3x squared on both sides of the equation. Over 3x squared, over 3x squared. So this one cancels with that one. And therefore, dx, this dx will be equal to du all over 3x squared. So we have expressed the dx in terms of du. Therefore, we go back and now substitute in the given integral. So we shall say that now this equals to 2 the integral of x squared all over u. Our now dx, which you have expressed in terms of du all over 3x squared. So x squared will cancel the x squared, and then we have 2 the integral of 1 all over u, then du all over 3. So from there you can easily spot that there is a constant which is 1 all over 3. We take it out of the integral sign. So here we have 2 all over 3, the integral of 1 all over u, then du. So when you integrate 1 all over u, you get the natural logarithm, which is ln of u. So this equals 2 all over 3 ln of u plus a constant of integration. So we substitute the value of u by x cubed minus 4. Therefore, this equals to 2 all over 3 ln of x cubed minus 4 plus a constant of integration. Thank you for watching and listening.